Amides are a carboxylic acid derivative that basically has had the hydroxyl portion replaced with a nitrogen. Now, the nitrogen has to have 3 bonds on it, so to that nitrogen, you're going to have other things, either 2 hydrogens, or a hydrogen and an alkyl group, or 2 alkyl groups. If you look at an amide, you can see that visually it is a condensation product of a carboxylic acid and an amine. You see water removed and you join the two. Regardless, it cannot be made this way. When you mix a carboxylic acid with an amine, you're mixing an acid and a base. So you're going to have proton transfer occur, and it's very fast. So once you add an amine to a carboxylic acid, the proton transfers to the amine. Now it is protonated and non-nucleophilic. And the carboxylic acid has been deprotonated. It has a negative charge, and so now it's non-electrophilic. So by just mixing the two together, you cannot make an amide. Amides, this group right here is this group of atoms right here are very planar. In fact, the carbon is trigonal planar, and the nitrogen, even though it has a non-bonding pair, is also trigonal planar. And that's because the non-bonding pair is in conjugation with the carbonyl. That makes this nitrogen trigonal planar, and the non-bonding pair perpendicular to the plane and in conjugation with the pi orbitals of the carbonyl. So it's planar. Because that non-bonding pair is in conjugation with that carbonyl, this is going to be non-nucleophilic. And because the double bond here is actually spread out through these 3 atoms, you have it's not very nucleophilic, and it's not like it's a true double bond with a large del negative up here on this oxygen. Some of that del negative is over here, so it reduces its reactivity. So what do you need to know? Amides are relatively non-reactive. You can put them in acid or base and they don't react. You can get them to react with acid or base if you heat them. So you can hydrolyze them down to a carboxylic acid with acid or base. Now, the nitrogen in an amide can be unsubstituted. What does this mean? This amide right here can have just hydrogens on it. So the alkyl group here would be gone. That's an unsubstituted amide. But the nitrogen can be substituted. As I'm showing you right here, this nitrogen has 1 alkyl group on it, but it actually could have 2 by removing the hydrogen and putting another alkyl group. Both types of amides have similar characteristics, so there's very little difference between a primary, an unsubstituted amide and one that's monosubstituted or disubstituted. They're all non-basic and all with a relatively low reactivity. The amides can hydrogen bond both with each other and with water. Now, the ability to hydrogen bond with water increases its water solubility. The ability to hydrogen bond with itself actually causes a very high boiling point and even a high melting point. The melting point is further enhanced because the amide is planar, and so amides tend to have pretty high melting points. Always remember, amides are non-basic because that non-bonding pair is not available and is conjugated with the carbonyl. Okay. Of course, amides can only hydrogen bond if you have hydrogens on the nitrogen. So if you've got a monosubstituted amide or an unsubstituted amide, they can hydrogen bond. If you do not have a hydrogen on the nitrogen, if it is disubstituted, you will not have it hydrogen bonding with itself. The amides are named as alkanamides. What does this mean? You find the longest chain and name the alkane, take the E off and put amide on the end. So the amide with 5 carbons would be called pentanamide. But another way you can look at it is, is that you name the acid that the amide came from, or that you can hydrolyze it to, and you remove the oic acid part and you replace with amide. You can think of it either way. That's fine. When the nitrogen is substituted, we name that substitution, the alkyl group on the nitrogen, as like we would an alkyl substitution on the rest of the chain, except we put, instead of a number, we put N in front to give its location. Let's look at some examples. Right here we have the amide that is made from 4 carbons, so that would be butanamide. Another way to say is this could be from butanoic acid, so we take off the oic acid and add amide. Regardless of which way you do it, you still get butanamide. Now, we have substitution on the nitrogen, and we have substitution on the carbon chain. The carbon chain is going to be numbered 1, 2, 3, so that's 3-bromo. And then the methyl group is on the nitrogen. We call that N-methyl. Go ahead and you try this one on your own. Okay, first thing, let's count the carbons on the carbonyl side. 1, 2, 3, 4, 5. That would be pentanamide, but there's an ene in there. So what we're going to say is 1, 2 pentene amide. Now, on the nitrogen, you have 2 methyls substituting it. So what do we say? We say N,N dimethyl. Go ahead and try this one. Okay, let's look at the carboxylic acid side, and we see that there are 3, so that's going to be propanamide. But on the number 3 carbon, we've got a phenyl group, so it's 3-phenyl propanamide. On the nitrogen, we've got an isopropyl group, so we're going to call it N-isopropyl.